Let's continue with this one over here. So we have y to the fourth, right? This quantity is just everything inside raised to the third power. Okay, so this immediately, if we're going to just reflect back on, okay, which rule do you think that was? And maybe you'll be able to point it out immediately. This would be the power rule. We have an exponent raised to another exponent, or they say like a power raised to a power. Okay, so this is simply just going to be multiplication, and this would be y to the 12th. Okay, remember this is the same thing as writing the quantity y fourth. How many times? Three times. Okay, remember this exponent tells you how many times to write whatever is inside there, that many times to multiply it by itself, right? And then this is the product rule, and we know with the product rule we just add and we just get y to the 12th. So two different ways that we can solve this. Of course, this is the fastest way here. Question like this now, like x squared y raised to the fourth. Okay, what I'm going to do is I'm actually just going to show how to do this the longer way first so we can kind of see it, and then I'll show you the shorter way. So this is really saying take whatever is inside this parentheses, right, and write this out and multiply it four times. So bam, 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 bam. Okay, then if we were to then go ahead, we'll say, okay, well, how many times are there x to 2's? We'll see that there's the same base. There's an x here as a base, 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 base. They all have the same variable. And so now we just have to use the product rule since we're multiplying and add up all of these exponents that are associated with the x. So 2, 4, 6, 8. And then here we have y, 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 all the same base. And then if we were to add up all their exponents, and you're probably like, well, there's no exponents. Well, this really is. It's really just a 1 next to each one right there, right? So there are 1, 2, 3, 4 of them, and this would be our final answer. If, however, we were to use the properties, I think one of the easiest ways that I would do this is I would probably put the exponent, I'd probably fill it in, okay? That way I know that when I break this apart, this is really the same thing as me writing x squared, right? X squared raised to the fourth, and then y to the first raised to the fourth, right? So then I can immediately see, oh, power rule, 2 times 4 is 8, 1 times 4 is 4. And we'll end up with the exact same answer than if we were to write it out, right? But at least you get to see what it looks like and then how the properties work. And it makes it a little bit easier to understand. So some of the more challenging questions now is 6x to the 7th over 2x to the 4th. Okay, just want to recall, what do you call the 6 in the front? Okay, these are not the bases. These are coefficients. All right, x would be considered the base because this has an exponent attached to it. So these would be considered the base, and then that 7 would be considered the exponent. Okay, don't want you to confuse the difference between an exponent and a base. All right, so now when we're doing this, I'm just going to write this over so it's a little bit easier to look at. Okay, you're going to multiply, add, divide, subtract all of the coefficients, right? That's these guys, the same way, using the same operations as you've always done. So this is 6 divided by 2. This will give us 3. Okay, we know now there's a base and a base that's exactly the same. That's an x. And it's the quotient rule since we're dividing. So 7 minus 4. And this leads us to get now 3x to the third. Okay. Going on with some more examples, and again, I would really strongly recommend that you pause and you try to solve them on your own. You just have to simply press the space bar, pause it, and then you can try it. And then, if you don't understand it, then just continue with the way I'm doing my videos, and then just, keep pausing and doing it until you get it. So same thing here, coefficients are being divided. Okay, so we're going to do that normally. 8 divided by 4 is 2. And then here we're just going to subtract the exponent, so 2x to the third. Okay. Now here is a little bit more complicated. I'm not going to write this out the long way. We're going to actually just try to use the properties. Okay, so this is going to be 2d to the fourth. Okay, all of this squared, and then cd all raised to the 5th power. And we're gonna just go back and try to figure out what is that we can do. Now, I know that this whole thing is being raised to the second power. What I don't want to do is I don't want to accidentally just focus here and forget about all of this, because this is part of the parentheses. So what I'm going to do is I'm going to go and I'm going to fill this in, right? This is really 2 to the first, right? This is really c to the first power. This is also c to the first power, d to the first power. So now I kind of know what it is I'm looking at, right? So each letter and number is being raised to the second power. So this is really 2, right? 1 times 2 is 2. 2 to the second power. This is going to be c to the second power. This is d to the fourth raised to the second power. Well, here I can multiply, so d to the eighth. Okay, this is c to the fifth and d to the fifth. Now, is it a necessity to put the ones? Absolutely not. If you can look at it and know that each term, or I should say each number and letter is being raised to the power on the outside, then there's no need to put the ones. Okay. So anyway, continuing from here, we're gonna end up with now 2 to the second is 4. Then we have, remember, c to the second times c to the fifth. This is the product rule here, right? 2 plus 5 is 7. And then d to the eighth times d to the fifth, same exact basis. We're just going to add. And this would be our final answer, just like that. Okay? All right. So, again, I believe in doing a lot of practice, so we're going to do a lot of practice. We have like 30-something questions of practices, so you can stop as soon as you feel comfortable. But I would, of course, urge you to do them all. All right, so this is going to be now 2fg to the fourth. Okay, all of this raised to the fourth power times now fg to the sixth. Okay, this is a very similar example as the last time. I'm going to do it without putting the ones. So you can also see that aspect. So this is 2 to the fourth. Okay, maybe I'll write it here. This is going to be 2 to the fourth. Okay, and then what we're going to then do is, it's going to take me some time to erase and stuff. This is going to then be f to the fourth. Okay, so f to the fourth. All right. Then after that, we're going to have g to the fourth raised to the fourth. So this right here, we can just multiply, and we're going to get g to the 16th power. That's the power rule. Okay. Times, and you can put this in parentheses if you'd like, right? F to the sixth, and then again now g to the sixth. Okay. Cool. So we're still not done yet. We then have to, simplify this. So 2 to the fourth, you can leave this as 2 to the fourth if you want to. I know that 2 to the fourth is 2 times 2 times 2 times 2, and that's 16. So maybe I'll leave it as 16. F to the fourth times f to the sixth. At this point, you might be able to start recalling some of the properties. So we're multiplying. We have the exact same base here, right? F. So we're going to add the exponents. So it's going to be f to the 10th. And then g, same bases. We're going to just add these exponents, right? So it's going to be 22. So our final answer is going to be 16 f to the 10th g to the 22nd power. Okay? And you'll see now here why learning your properties is actually pretty beneficial, because imagine having to write this out 4 times, having to write this out 6 times, and then counting everything. It just takes way too long. Okay? Same thing here. So let's see, x to the 5th times y to the 6th all over xy squared. Right? Follow the same thing. The main thing that you'll see here going on is that we have a division. So a division means that we're going to be using the quotient rule. So we have the same x on the top and the bottom. Okay, you can place the little 1 here if you'd like, just because with a quotient rule we're going to be subtracting. So if you didn't see the 1 there, you might think, oh, it's just 5 minus nothing, which is not true, right? There is a 1 here. So this would be 5 minus 1. And then the y's on the top and bottom, we just subtract the exponents, 6 minus 2. And we're left with now x to the 4th, y to the 4th. Okay, I like to put a box on my answers. Okay, down here a little bit more extra practice, right? X squared times y to the 5th over xy to the 4th, all right? Notice we have the same variables here. So I'm going to go ahead in a different color, just add a little 1 there. And now we're left with x as our base, right? This is a base because it comes with an exponent there, right? So 2 minus 1, and then y times 5 minus 4, subtracting the exponents, and we're going to get x to the first, y to the first. This is a totally acceptable answer. Okay, but we're not going to write it like this. We're going to just write it as xy, since there is no need to put a 1 there. Right? It's like saying 1x. There's no reason to put a 1 there when you can just write x. Okay, it's still right, but there's just no need to have it there. Okay, so let's continue with just a few more. Okay, this looks like it might be a little bit more challenging. So we have 4x to the 5th times y over 16xy to the 4th. Okay, all of this raised to the 3rd power. Now this would be crazy to write out. Okay, but and even if it's not, like, just think about this. Technically speaking, we're supposed to be raising each one of these, right, to this 3rd power. That would be insane. Look, all of this. That's too much work. So you have to find ways and recall things that you've learned before. So we've learned like order of operations before. We know that you always start inside the parentheses. And inside this parentheses, there are some things that we can simplify, like this 4 over 16. Okay, what's 4 over 16 when you reduce it? It's just 1/4. Divide the top by 4, the bottom by 4, right? So let me go back really quickly just because I want to be able to take that out there. Okay, over here, we have x to the 5th divided by x. Okay, so even though it's written inside here, there's still division occurring. So this is really the same thing as using the quotient rule. So I can write x to the 5 minus 1, which is 4. Okay, then here we have y to the 1st power divided by y to the 4th. So on the side here, I'm going to write that, right? Y to the 1st over y to the 4th. This is the same thing as y to the negative 3, but the negative 3 is a negative exponent, so we have to flip it back to the bottom and it becomes 1 over y to the 3rd. Okay, so I'm going to write 1 over y to the 3rd. And all of this, right, still inside the parentheses, 3rd power. Now what I'm going to do from here is that this doesn't look too nice. Okay, here we have a fraction, here we have a whole term, here we have another fraction. So what I'm going to do is I'm just going to put a line and see where this 1, this x to the 4th and this 1 is. Okay, all of this can go on top. Now there's no need to put the 1 there. And then the 4 on the bottom and the y to the 3rd, we could just multiply them together like that. And now we have something that we can definitely make smaller. So here we just have a power rule. And that power rule is going to be each one of these being raised to the 3rd power. So x to the 4th to the 3rd power is going to be x to the 12th. Right? 4 to the 3rd power, you can leave it as 4 to the 3rd power. 4 to the 3rd is 4 times 4 times 4, which is 64. So if you want to put 64, you can. And then y to the 3rd raised to the 3rd is y to the 9th. Okay, so a much larger problem. But even and this was long even with the properties of exponents. So you can only imagine writing everything out would be insane. Okay, so I'm actually going to put a pause on this and we'll continue another video here because I don't know how long my videos can be to upload.